it's Kevin, your dance instructor. Now let's get ready, okay? First step is to stretch out these nice muscles before we actually get into the hard stuff.
Hey Claire, what you doing there?
Nothing much. What's up?
You want to learn how to super spin?
Heck yeah.
Well, first you gotta stand there like a normal human being. Now put your hands up, and you're ready. Now gain some angular speed, buddy. Oh, whoa, you're getting too fast. Now put your hands out, and you're slower. So Stuart is doing the super spin, but let's talk about what happens when he changes his arm to this. Now he starts to slow down. Why? Now I can explain this with two equations. You have the angular momentum equals the moment of inertia times the angular speed. And also you got the moment of inertia equals the sum of mass times radius squared. It's gonna be the same for both when his arms are up and down, but the radius is different. So when his arms are up, the radius from the center of rotation is smaller, but then when he starts to extend it away from his body, R goes up. So come over here, Claire. When radius rises up, moment of inertia increases too. But when moment of inertia increases, angular speed goes down. This is because angular momentum is conserved. In conclusion, the moment of inertia and the angular speed are inversely proportional. When one goes up, one goes down.
Hey guys, I just got promoted to instructor, so now I'm gonna teach you my favorite dance move, the leap. Okay, Kev, you ready to learn how to leap?
Yeah.
Alright, first step is to take 3 steps backwards. Very good. Now get a running start and launch yourself into the air. That was excellent! Okay, let's take a look at the path Stuart takes when he leaps off the ground. It's gonna look like a parabola, something like this. We're going to look at the x and y velocity components at different points along Stuart's path. We're going to look at point A, B, C, D, and E. Talk about velocity in the x direction first. The velocity in the x direction of Stuart's leap is going to be constant the entire way through the leap. Vx, 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 and Vx. Velocities in the y directions are a little different. The velocity in the y direction at point A is going to be an equal value to the velocity in the y direction at point E. However, the velocity at point E is going to be negative. The velocity in the y at point B is going to be the same value as it is at point D, except it will also be negative over at point D because Stuart will be traveling downwards. At point C, velocity in the y will equal 0 meters per second.
We forgot the most important aspect of dancing, the music.
Yeah, Uber everywhere, pre-rolls in my Ville, hey.
Let's relate music to physics. Now, what I used to think is that music looked like this, a transverse type of wave. But in reality, it's like this.
No, it's not.
This, a longitudinal wave.
Now, when you're listening to a high-pitched and really fast song, the wavelength is going to look like this, with a really small wavelength and a small amplitude. Travis Scott hits you with the bass drop, the wavelength's going to look more like this.
really big amplitude and really big wavelength.